Alright, so we have to solve this using the first principle method. Then how do we solve this? First of all, we have to find the change that occurred in both sides of the equation. Then finding the change that occurred in both sides of the equation, what do we have to do? We have to, let's say solution. We have y is equals to x raised to the power of 4. Now, from here now, we have this to be finding the change that occurred in both sides of the equation. We have y plus the change that occurred in the variable y is equals to x plus the change that occurred in the variable x. Then remember that this is raised to power of 4. We raise it to the power of 4. This power of 4 here means that this bracket is into 4 places. So what do we have to do? From here, we go to the next step that says we should minus both sides by y. That is subtracting y from both sides. We have y plus the change that occurred in y minus y is equal to x plus the change that occurred in x all raised to the power of 4, then minus y. We can define our y here, but to make it cumbersome. But from that, let's open this bracket. Let's open this bracket first. But before then, we have two common terms here that can cancel out. We have minus y and plus y. We remain with the change in y is equals to x plus the change that occurred in x, then raised to the power of 4 minus y. Then what do we have to do here now? We open this bracket into 4 places. Opening it into 4 places, now we have dy is equals to x plus the change that occurred in x, bracket x plus the change that occurred in x, open another bracket, x plus the change that occurred in x, open the last bracket, x plus the change that occurred in x, then minus our y. 1, 2, 3, 4 brackets. Then from here now, what do we have to do? We have to take 2 brackets at the same time and multiply out. You can also use the binomial method to solve, but for easy step, let's take this, multiply this, and take this and multiply themselves. Then after we use this to multiply this to get our answer. Then doing that now, what we have? We have the change in y. Change in y is equals to x multiplying this x, we have x raised to the power of 2. X multiplied by change in x, we have plus x change in x. Then change in x multiplied by x, we have plus x change in x. Then change in x multiplied by change in x, we have plus change in x raised to the power of 2. We have this bracket. Then this bracket also, since they are the same thing, you repeat this. X raised to the power of 2 plus x change in x plus x change in x, then plus change in x raised to the power of 2, then minus y. So in this case now, we have to collect like terms. Change in x are 2 here, change in x are 2 here. To collect them, we have change in y. Change in y is equals to x raised to the power of 2 plus this, we have 2x raised change in x, then plus change in x raised to the power of 0. So the same thing happens here. We have x raised to the power of 2 plus 2x change in x, then plus change in x raised to the power of 2, then minus our y. So since we have collected like terms here now, then I may have change in x raised to the power of 2 here and change in x raised to the power of 2 here. You limit change in x to 0. Limiting change in here, x here to 0. So we have this to work with and this to work with. Then why we're limiting this is for easy simplification. Otherwise, you would have used this bracket to multiply this bracket by binomial method. So, but to make it cumbersome as well, so we just limit change in x to 0. Then limiting change in x to 0, we have change in y is equals to x raised to the power of 2 plus 2x change in x. Then open another bracket, x raised to the power of 2 plus 2x change in x, close bracket, minus y. So doing this now, we use this bracket to multiply this bracket. Doing that, we have change in y is equals to x squared multiplied by x squared. We have x raised to the power of 4. Then we have x squared multiplied by 2x change in x. We have plus 2x raised to the power of 3 change in x. Then 2x change in x multiplied by x squared. We have plus 2x change in x. This is x raised to the power of 3, which is x cubed. Then 2x change in x multiplied by 2x change in x. Then we have it to be plus 4x squared change in x squared. So we have minus y. So doing that now, what do we have to do? We have to collect like terms. We have this to collect, then we define our y from the next step. So doing that now, we have it to be equals to change in y is equals to x raised to the power of 4 plus 2x cubed change in x plus 2x cubed change in x. We have 4x raised to the power of 3 change in x, then plus 4x squared change in x squared minus y. Then from here now, we can define our y. Defining our y, remember you said that y is equals to x raised to the power of 4. So we compute x raised to the power of 4 in place of y. Doing that, we have change in y is equals to x raised to the power of 4 plus 4x raised to the power of 3 change in x plus 4x raised to the power of 2 bracket change in x raised to the power of 2 minus open bracket, we have x raised to the power of 4. X raised to the power of 4. We close bracket. So doing that, what do we have to do? We have to open the bracket. Opening the bracket now, what do we have? We have change in y is equals to x raised to the power of 4 plus 4x raised to the power of 3 change in x, then plus 4x raised to the power of 2, then change in x raised to the power of 2, then minus. Then minus times x raised to the power of 4. We have minus x raised to the power of 4. We have common terms, like terms that can subtract themselves. So subtracting themselves now, what do we have? We have this and this. Then we cancel out. Since they have cancelled out, we have change in y is equals to 4x raised to the power of 3 change in x plus 4x raised to the power of 2 change in x raised to the power of 2. Now from here, what do we do? The next step we have to look into is to divide both sides by change in x. Dividing both sides by change in x, we have change in y all over change in x is equals to 4x raised to the power of 3 change in x all over change in x. Then plus 4x raised to the power of 2 change in x raised to the power of 2 all over change in x. Then from here, we cancel change in x, we cancel change in x. From here, we cancel change in x, we cancel change in x here now. So here, we remain with one change in x. From that place, what do we have to do? We have change in y all over change in x is equals to 4x raised to the power of 3. Then plus 4x raised to the power of 2 change in x. Then from here now, we go to the last step. And the last step said we should limit the value of change in x tends to 0. He said lim change in x tends to what? 0. Limiting change in x to 0 now, what do we have from that place? We have it to be change in x all over change in y over change in x is equals to 4x raised to the power of 3, then plus 4x raised to the power of 2, then 0. And remember that everything here becomes 0. Since everything here becomes 0, then we are left with 4x raised to the power of 3. We have change in y all over change in x is equals to 4x raised to the power of 3. This is our final answer. Thank you so much for watching. If you find this so interesting, please subscribe to my YouTube channel and also to my Facebook page at Noble Online Maths. Thank you and God bless you.